Hello everyone and welcome to Fulton School's Tutoring Center Math 265 Prerequisite Workshop. So this might seem as a heavy name, but in this sense, essentially, this workshop is basically going to be the hacks that would make your Calc 1 easier, basically. So this presentation is typically going to be covering three topics: simplification of functions, finding slopes, and areas. Why do I emphasize on these 3 points is because throughout Calc 1, in several topics, knowledge of these ideas would just make the question easier for you, or it would make it easier for you to understand how to find the answer in a specific scenario. So I'm just going to go ahead and explain these topics. Before that, of course, if you'd like more updates from FSC Tutoring, follow us on Instagram and Facebook, and there's where we'll have more info of such sessions that will follow. Of course, today's presenter is me, Sanjana Shah. I am a computer science major. I'm a sophomore and I am a special programs tutor, which means that I'll be specifically tutoring programs for freshman students. Of course, I already stated the learning objectives, which were simplifying polynomials, calculating slopes with different methods, and just recollecting the common area and volume formulae. So when we're discussing polynomials, this concept would keep coming throughout Calc 1, where you have been providing with a specific question, and in the first look, the question looks like really complicated with too many fractions involved, and it just doesn't make sense which formula would apply or which technique do we start with. So whenever you feel like that, when it comes to Calc 1, it would be a good idea to take a good look at the question. Sometimes it would have a trigonometry concept or an algebraic identity, which could be simplified with some simple formulas, such as the ones on the next slide. They would look something like this. So at some point, maybe they would have used sine squared theta plus cos squared theta, which just translates to 1. So the fraction isn't really that big. Or them writing a square minus b square, which translates to a plus b, and a minus b, which might be cancelled out with the fraction. These are general properties that would have been covered in pre-calc and college algebra, which if you just keep remembering would make solving problems like really easy. Because sometimes it's just the question trying to intimidate you, while it's actually just really simple. For example, this is the given problem. Cos square of theta into tan square theta plus 1. Now, in this case, a very simple way to put it would be go back to the properties I listed before, such as these. In this, if you pay attention to this one specifically, tan square theta plus 1 is equal to 6 square theta. So when it comes to this question, tan square theta plus 1 would just become 6 square theta, just secant square theta. Now, another relation that's pretty well common is that cos theta is equal to 1 upon 6 sec theta. So if this is the question, it can be rewritten as cos square theta divided by cos square theta, which is essentially equal to 1. So our entire question at this point, cos square theta into tan square theta plus 1, was easily transformed to just 1. Such questions would be fairly common in a section called limits, which is, so if we are dealing with calculus, Calc 1 basically, it would be divided into 3 sections. Not like upfront, but if I were to ask you at the end of Calc 1, what were the 3 sections in Calc 1, you are most likely to say limits, differentiation, and integration. So these terms might not make sense right now, but for them to make sense better, it would always be a good idea to be clear about these techniques. These questions. Obviously, of course, there are more, and if you could remember more, it's much of a benefit, but it would be Really important to keep these in mind while doing the calculations. Next topic is calculating the slope. Now, the idea of the slope comes from graphs basically. So if this is your graph, slope is basically the angle at which the line is tilted in the most literal sense. But why is it important to know how to calculate slope in Calc 1 is that there is a concept of differentiation, which is essentially a setup in which we try to convert real life situations into graphs, such as my speed when I was walking a certain distance. And in that topic, the slope of the graph would give very important results. In that graph, if you could calculate the slope, you would directly know what my speed is. So in that sense, knowing how to calculate slope using different quantities would just give you the answer really quickly. So two fairly common ways in which the idea of calculating slope would be hidden in Calc 1 would be, first would be that they would give you a graph in as given in the figure, and then they would give you the angle at which the line is tilted with respect to the x-axis. So a normal idea is that usually the slope is the tan of the angle. In this situation, theta, the slope would be tan of theta. When it comes to the slope formula, if in the question you are not been given the angle, if you have the angle, that just makes your life easier. Take the theta, plug it into the calculator with what is the tan of theta, and you know the answer of the slope. But in case that is not what you're looking for, or not the best information given, you can always go back to the slope formula. How does the slope formula work? Basically, if there are 2 points given in a line, such as this point and this point. So slope formula basically figures out the x and y coordinates of these 2 points and tries to convert it in the form with which we can find the slope. In this case, the slope is equivalent to the difference in the y coordinates divided by the difference in the x coordinates. Going ahead, let's do a question that will make this simpler. For example, we're going by the same question. There is a given graph, and it has already been stated that the theta at which the line is inclined is pi by 4. So if the theta is given, then the slope of the line is equivalent to the tan of theta. So in this case, it would be tan of 45 degrees or tan of pi by 4, which would be equal to 1. As simple as it may sound, most of the questions would be answered by using theta in Calc 1. Another question could be, in this case, if the question is that our two given points are 4,5 and 8,15. If that is the question and we need to find the slope, so in this scenario, your x1 would be 4 and x2 would be 8, while y1 would be 5 and y2 would be 15. So based on the previous formula, our slope should be equal to y2 minus y1 divided by x2 minus x1. This would translate to m is equal to 15 minus 5 divided by 8 minus 4, which is again equal to 10 divided by 4, which would further simplify to 5 divided by 2. So in this case, our slope becomes 5 divided by 2. Moving forward, the next topic is basic areas and volume. Uh, the idea of involving basic areas and volume is would be helpful in differentiation and partly in integration. So Calc 1 will use these areas and volumes and try to find their relations with other quantities. But to find their relation with other quantities, you need to know what the base quantity is. For example, if I want to find velocity, I absolutely need to know that velocity is actually equal to distance by time. So in the same sense, for example, if I want to find area for a triangle, I must know that area of a triangle is half into base into height. However, and a lot of the exams, there is a good chance that these measurements would already be given in the exam beforehand. Like there would be a test sheet and there would be an extra sheet which would have the info of the volumes and surface area of these shapes, but it would always be helpful to just memorize it so you don't have to flip back and forth between the extra paper and your test paper. Also, before every exam, it would be a very good idea to ask the professor beforehand if these quantities would be mentioned in the question paper. So basically, do I need to learn it or are you already going to provide it? That completes the main topics covered here. Before we move ahead, I would like to take one question again based on the previous topics that I highlighted. So as I talked about the algebraic identities, if the question goes as simplify a square minus b square divided by a minus b. So I could write it in a different way as a minus b into a plus b, the entire thing, divided by a minus b. Now, it's fairly clear that this a minus b and the a minus b in the numerator are going to cancel each other out. So when you look at the further value of the question, it only turns into a plus b. That is what remains. So while it might seem like a simple calculation, in Calc 1, it would be slightly more difficult to do calculations on exponents than it would be on simpler numbers like these. So if you're well aware of these formulas, it would just make the questions simpler. To summarize the entire presentation, I would like to go back and explain why did I include each of these things in this presentation, or why are they the hacks for Calc 1. Of course, simplification, to be very honest, it would be used everywhere in Calc 1 and Calc 2 and Calc 3. A basic knowledge of these identities would make you just see the question slightly differently. It's very, very common for the test to show the question as something really complicated. But when you like pay a lot of attention, you'll start seeing patterns and it will make sense that, okay, these things cancel out or these things are just equal to 1. And that will make calculations much, much easier when it comes to any topic in math, essentially. For example, if we consider the graph of tan theta, a good question could be, what happens to the value of the graph of tan theta when we approach 9 degrees? So if we know the graph of tan theta, everyone knows that at tan of 90 degrees, the graph actually approaches to infinity. So in that case, because it's infinity, it does not specifically reach a point, so there is no limit. On the other hand, if I ask you what happens when the graph of tan theta approaches 0 degrees, we do know that tan of 0 degrees is actually 0. So I can say that when it approaches like really close to 0 degrees, it's going to be 0. But for that, I actually need to reach to tan. So instead of tan, the question would just go ahead and say square root of sec square theta minus 1. But it's fairly common that sec square theta minus 1 is actually tan square theta. And square root of tan square theta is tan of theta. And that just made the question easier for you. On a different hand, slopes would be used in situations which are expressed graphically. So if I want to explain by a graph that what was my speed at any given point, then the question would employ graphs. Whenever we're talking about graphs, slopes can be very helpful in understanding how quickly the quantity is changing in a graph. So if you can calculate the slope, then you would basically know how quickly the y-axis is changing with respect to the x-axis. For example, if the y-axis has distance and the x-axis has the time, so slope basically would be distance by time, which is velocity. So using the slope, I can tell you the velocity based on a graph of my distance. So differentiation is basically going to be about finding a different quantity from the quantities that are given to you. If I have distance and time, you will be finding velocity using differentiation. And for that, you'll need to know how to calculate slopes. Lastly, areas and volumes. So differentiation, the later parts of the derivatives, differentiation also called derivatives, would be filled with questions in which you'll be dealing with real life situations, like how quickly is a tank going to fill up, or how quickly is it going to drain out, or how, if the volume is increasing at this pace, how quickly is the surface area increasing. These questions would be made so much simpler if you already know the volume and the surface area. You will fairly with talks that how quickly does the tank empty. It would just make sense to know the formula of the volume of a tank, which would be in most scenarios a cylinder, which would be the formula of a cylinder. So based on these questions that come around repeatedly in Calc 1, I had laid down these 3 points: simplification, slopes, and areas and volumes. And beyond this lecture as well, it would be a good idea to make a list of these topics and refer to them from time to time, or in fact, even when they just come up, that these topics would fairly like take 1 page of space. So you might just want to add it to your notes. So every time these topics come up, you can always refer back to your notes to find these identities. And that concludes the presentation.